Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Currently we are in the fourth module where we are studying different taper turning operations. Now in the previous lecture we have seen some taper turning operations. They are offset taper turning and swiveling taper turning processes, and now in this lecture we are going to see some more taper turning operations and also lathe specifications by which any lathe machine is specified and taken into particular application. Now, this is the third method out of the 5 methods which are used for taper turning. First of all, we should remember what is taper turning. So, taper turning is nothing but turning the metal object or a cylindrical object into this inclined shape. So, this cylindrical object will have two different diameters, that is this small diameter and this one is larger diameter, capital D, and then we have length of the object, that is L. So this is how it is done, like the smaller diameter and larger diameter. There are two diameters for this type of object. Okay, this process of making this taper is called taper turning. If taper is not there, we can do simple turning. Simple turning is nothing but we can simply get a cylindrical object of the required diameter. So the diameters on the both sides is same. If we want to get a taper turn, we have to decrease the diameter on one side and we have to keep some angle here. This angle is also important. This angle is called taper angle and it is also given by the designer sometimes, or we have to calculate by using some kind of formula depending on the diameters. Okay, so in the previous lectures we have seen two processes. First one is tailstock offset method, and second one is compound rest swiveling method. So by now we should be knowing what are these terminology, because we are studying these processes and terminology from the last few lectures that is related to lathe machine. So tailstock is the object that is placed on the bed of the lathe machine, which is used to support workpieces. But now in this method, the tailstock offset method, the tailstock has a very particular application. We have to keep a ball arrangement into the tailstock by which we can keep the tailstock offset with the center line of the workpiece. Okay, so the tailstock offset method itself indicates the tailstock center has to be kept in offset with the center line of the workpiece which is rotating. And in compound slide swiveling method, we have to calculate the taper angle or the angle that is given by the designer. We have to use that angle for rotating the tool post. So the compound tool post has to be rotated through this angle, and then we have to give the feed for removing the material where we can get taper turning. Okay, so this is how the first two methods are done. Now in this method we are going to study how taper turning is done. So the name of this method is taper turning by form tool method. So in this type of taper turning method, a straight form tool with a taper angle is set with a taper cutting edge. This is very simple. See here, this is the workpiece. Here we have to get a taper. Okay. Now in order to get taper, in the first two methods, we have used different techniques. Now in this method, simply we have to keep the tool which is itself inclinedly made. See here, the tool is like this. So the tool itself is inclinedly cut. Okay, whenever I touch the tool on the workpiece, it will form a taper. I don't have to do anything. I simply keep the workpiece rotating and I will give the feed and depth of the cut for the tool which will create a taper. So this taper is formed like that. Okay, this is the simplest form, but it has a disadvantage. it can create taper angle that is equal to the angle of this particular tool. Okay, we cannot get any angle here. Okay, when we are in compound swivel method or tailstock offset method, we can get required angle as given by the designer. But if this process has to be used, we have to use the angle that is predefined by the tool itself. The tool has an angle which is predefined, and this angle of taper can be possible on the workpiece. Okay, so this is predefined. We cannot change the taper angle of the tool. Okay, so this is a very simple process, and it is given a direct feed on the job so that it creates a definite form on the job. But the advantage of this process is we don't have to worry about giving the feed. It will create the taper instantly and precisely. Because the tool itself is tapered and it has some taper angle, it will create the taper shape of the same angle. The drawback of this method is that more force is not generated because more area come in contact between the cutting edge and the workpiece. So the disadvantage of this process is the cutting tool will have more surface contact area. That means, see here, this part, this entire part should be in contact with the workpiece so that it will create more what we call friction. So it requires more power to do this operation. Okay, we should apply more force in order to do this so that we'll get a taper turn. So this is the only drawback of this process. Due to the reality of the taper turning, this form tool method is only used for short length tappers. We can simply see this from the diagram itself. This taper, how much length of the taper can be obtained? Only up to the length of this area. We cannot get a bigger taper by using this tool. Okay, so that is why this process is limited only for short lengths of the taper. Short lengths of the taper can be easily performed or turned by using this type of method. Okay, so this is all about taper turning by form tool method. And then we have another process, that is combining feeds method. So in this we can combine feeds, that is longitudinal feed and cross feed. By combining these two, we have to give the taper. So this is very hard because it requires skilled operator. We cannot do simply by giving the feed. We may remove the excess material and we may lose the taper. Okay, in such method, a longitudinal and cross feeds are performed simultaneously so that the tool moves along the diagonal path. So see here, if we want to give a horizontal feed, we can simply give. And if we want to give a vertical feed, we can simply give the depth of cut. So if you want to give a taper turning, so what we have to do, we have to give the feeds. These two feeds has to be given at the same time. This is cross feed and this is longitudinal feed along the length of the body, length of the workpiece, and along the cross section of the workpiece. So this has to be given very carefully because it has to be done simultaneously. So the longitudinal feed and the cross feed has to be given at the same time. So in order to do that, we have to be very careful. Otherwise, we may not get this taper shape. Okay, the taper shape cannot be obtained. Okay, I'm drawing this wrong. So the taper has two diameters as always. So the taper has to be obtained by giving two types of feeds, that is longitudinal feed and cross feed at the same time. So see here in this picture, we can see there is a headstock. This is the workpiece and we have tool post which is supporting the workpiece at the center. See here carefully. In the previous method, that is the first method, offset method has been followed in order to get a taper turn. But in this method, we are using some other technique, but not the tool post technique. That is why the tool posting is kept in line with the center line of the workpiece, about which it is rotating. Now see here, the cutting tool is kept in contact with the workpiece and we have to give the longitudinal feed and cross feed at the same time. This has to be given very precisely, for which we need a skilled operator. And then there are some methods by which we can measure taper. Okay, so we have like 5 methods for measuring the tappers. So the first one is using plug gauge for internal tapper and ring gauge for the external tapper. So these are the devices. So plug gauges are the devices and the ring gauge is another device. These are very similar to strain gauges, which are used in engineering application for the measurement of the strain. Okay, the strain on a mechanical body can be measured with the help of this strain gauge. So the plug gauge and the ring gauges are very similar to this strain gauges, where they can be used for measuring the internal tapper or external tappers. Okay, so this is the first point. By comparing the newly turned tapper with the known tapper, we can compare the how much tapper is formed. Generally, tapper is nothing but the angle. Okay, tapper value, it might be an angle, or sometimes it might be the millimeters per meter length, that how much amount of material has removed throughout the length of the cylindrical object. And then we have second process called using the tapper test gauge. So we have a device called tapper test gauge, which is used to measure the tapper. And then we have third method using gauge blocks test mandrels. So these are some other methods by which we can measure the angle of inclination of the tapper. And then using sine bars and gauge blocks. We have sine bars, which are very popular in the case of instrumentation, where we can use these sine bars. It is not sine, it is sine, S-I-N-E. Sine bars are used for the measurement of the tapper. And then we have using a micrometer also, we can measure how much tapper has been given to a particular workpiece. Now that is all about different lathe operations that can be performed. And so far we have seen tapper turning operations. And now let us move to lathe specifications. Now see here, in lathe specifications, we have to have some specified values. So based on these specified values, we can identify a particular lathe machine, or we can select a particular lathe machine for the purpose. So depending on the type of application, different types of lathe machines can be used. We have wide range of lathe machines that are available in the market. Depending on the application or the operation we are doing, we have to select a particular lathe machine. So for selecting the lathe machine, we should have some specifications. So the specifications are like this. There are 4 types. These are the broad values by which we can specify a lathe machine. First one is swing. Swing is nothing but it is the rotational speed. It's not the rotational speed. It is the area through which the workpiece can be rotating. Okay, you can simply see here this area. It is colored pink here. So this pink colored area, which is noted as A, in this area we can make the workpiece rotate. Okay, the workpiece will be rotating in this area only. So this area is limited to some value, because the workpiece will not rotate into all directions. It will rotate in a direction, and it will rotate in an area through which the workpiece will be rotating. Okay, so this is called swing. This area of rotation of the workpiece is called swing. And then the second one is distance between centers. So see here, this is headstock and this is tailstock. The distance between these two centers, head center and tail center, these two centers, there will be a maximum distance. Okay, we are not talking about the minimum distance. They can be brought together as close as possible. They can touch each other. That is the minimum distance there, which is 0. But the maximum distance, that means the maximum length of the workpiece that can be inserted into the headstock while doing the operations. Okay, so this is the maximum length that is possible between the two stocks, that is two centers. That is the B value. So this value is called capital B, and it is called distance between the centers. And then we have C. This is length of the bed. So length of the bed also plays an important role. Depending on it, we can do some special operations, and sometimes we have to select the lathe machine which is smaller in size, and sometimes we have to select a lathe machine which is larger in size, depending on the applications, depending on the size of the workpiece. Okay, then the length of the bed is also taken into consideration. So this is the length of the bed between these two ends of the lathe machine. So by this we can simply identify the size of the lathe machine based on the value C. And then D, this is the radius 1/2 of the swing. So this radius, so we have seen there is a area around the workpiece in which it is rotating. So half of that value, half of the value of A, that is swing. So swing by 2 is equal to radius of the swing. Okay, so radius of the swing is also sometimes indicated as a lathe specification. Now let us see some specifications of lathe machines. First one is swing, and then B is nothing but maximum length of the object or the workpiece that can be held between headstock and tailstock. And then we have bed length. Length of the bed between the entire length of the bed is also taken, which may be included headstock and length. Okay, and then D, maximum diameter of the bar that can pass through spindle or collect chuck of the capstan lathe. So maximum diameter of the workpiece that can be attached into the headstock, this is also specified as a lathe specification. So some more specifications which are related to lathe machine are, now we have to see each and every lathe specification here. So this is maximum swing over bed. That means when the workpiece is inserted into the headstock, it will be rotating. While rotating, it should have some maximum swing. That means the maximum area with which it can be rotating is called maximum swing. Okay, and then the second one is there, maximum swing over carriage. What is carriage? Carriage is nothing but it is the object on the lathe machine which is used to hold the tool post and all things. Okay, tool post, tailstock, etc. all placed on the carriage only. Okay, headstock is separately fixed, which is attached to the motor and all, and on the headstock we will have a spindle and chuck. Okay, so maximum swing over the carriage is also taken into consideration. So if I fix the workpiece here, this is headstock, I will fix the workpiece like this. So this is carriage. This entire thing is placed on the bed. This is bed. This is carriage. On this carriage, I will have a tool post and I will have a tailstock. Okay. So this is tool post and this is tailstock. So this is workpiece and this is headstock. So the maximum length of this particular workpiece which is rotating, okay, here this area entirely is called as, it is also taken into consideration as a specification. So maximum swing over the carriage. So generally the workpiece will be some length, maybe X. So out of this X, some length of the workpiece will be inserted into the headstock. So the remaining object which is rotating in A, this is taken as maximum length, maximum swing over the carriage. And then height of centers over bed. So this is the bed, we have already written here. This is the bed. So out of this bed, how much height of the centers are there? So this is headstock center and this is tailstock center. So these values are also taken into consideration when we specify a particular lathe machine. And then maximum distance between centers. So maximum distance between centers is also already we have discussed about this. So distance from here to here is taken as the maximum distance between the two centers. And then we should have what is the length of the bed. So length of the bed is taken from here to here, and then width of the bed. Width of the bed in the perpendicular direction, it is also taken. So depending on the width of the bed, we can choose the type of workpiece that can be machined on this. Okay, and then Morse taper of the center. So the taper of the center is also taken into consideration. Okay, and then diameter of the hole through spindle. This is very important. Here we have in the headstock we have a chuck which is attached, and we have a spindle which will connect the headstock and the chuck. Okay, the headstock is a stationary machine inside which we have gears. It will not rotate. The gears inside headstock will rotate, which will make the spindle rotate. The spindle in turn rotate the chuck. Okay, inside the chuck we have a workpiece. So the chuck will be rotating at clockwise or anti-clockwise depending on the type of speed we have given, and the diameter of the hole of the spindle is also notified as a specification. Bigger the diameter of the hole, bigger the chuck we can attach, and bigger the workpieces we can attach. So depending on the size of this diameter of this spindle, we can get more size of the workpiece. We can machine larger sizes. And then faceplate diameter. So faceplate diameter is also given as an important specification. Okay, and then we have size of the tool post. So we have tool post here. So the size of the tool post is also taken into consideration. If the tool post is very small, we can attach only one or two tools. If the tool post is very large, we can insert multiple tools. Okay, so that we can do multiple setup operations one after the other by simply rotating the tool post. Okay, by simply aligning the tool along with the workpiece. So larger the tool post, more the number of tools that can be attached. Smaller the tool post, small number of tools that can be attached, so that we have to frequently change the tools for doing different operations on the lathe machine. And a number of spindle speeds. This is also very important. So inside the headstock, we have gearbox. So in gearbox, we have a single motor which is rotating at a constant speed. But we may not require the actual speed of the motor for rotating the workpiece. So we have to reduce the speed sometimes, or we have to increase the speed sometimes. By this, we can perform this increasing or decreasing of the speeds with the help of gears. We have to use a set of gears which is used to increase or reduce the speed. Okay, so some lathe machines will have 2 to 3 gears. That means 2 to 3 speed arrangements are possible. In some lathe machines, 4 to 5 gears are attached, which means we can get 5 different speeds possible on the same lathe machine. So this is very useful. We can do different type of metal operations or metal machining on the same lathe machine, because different metals require different machining speeds, which can be attained by different gears. Okay, by changing the gear which is in contact with the motor, we can get different speeds. Okay, and then lead screw diameter and number of threads per centimeter. Here we have a special device called lead screw. So this lead screw is the one which is used while thread cutting operation is done. So for thread cutting operation, we should operate this lead screw which is attached into which is engaged to the tool post, and by which we can get a helical thread cutting possible on the workpiece. Okay, so depending on the number of threads per centimeter on the lead screw and the diameter of the lead screw, we can specify a particular lathe. Okay, and then size of the electric motor. This is the first and foremost specification that can be given to any lathe machine, because the size of the motor which is attached to the headstock, it should be notified. It should be of 1 HP motor or 2 HP motor. Depending on the size of the workpiece we are working, we have to take bigger motors. If bigger workpiece has to be done, bigger motor has to be attached to the particular headstock. And then pitch range of the metric and inch threads. So the pitch range is used in the process of pitching the holes. I mean thread cutting operation, we used to see this pitch range. Pitch range will indicate whether it is taken in the case of metrics or inches. Okay, So this is also taken into consideration, because while we are manufacturing thread cutting on the particular metal rods, we have to take into consideration whether it is taking a metric process or inch thread process. Okay, whether the units are being taken in centimeters, meters, or inches. Okay, so this is also specified when we are considering a particular lathe machine for the particular applications. So all the lathe machines are specified by some of these specifications, or mostly all of the specifications, depending on their nature. So for a particular workpiece which is of diameter 10 mm, I have a workpiece which is 10 mm diameter. If I want to do machining operations on this 10 mm diameter workpiece on a lathe machine in which the headstock is having a maximum diameter, the chuck has a maximum diameter holding capacity of about 9 mm. For that, I cannot do this lathe machine. I cannot use this lathe machine because my workpiece is bigger. For getting a 10 mm workpiece, I have to take 11 mm workpiece, because after machining, I will remove the 1 millimeter. So, I will take a larger lathe machine which can hold larger diameter workpieces, for which I need more power and more energy. Okay. So, this is how the lathe specifications are very important. Sometimes I may want to machine a larger workpiece. The length of the workpiece is very large than the actual length of the lathe machine. So this one also has to be changed. So the length should be in very small length. Depending on the workpiece, we have to choose a particular lathe machine. So this is all about different specifications by which we can choose a particular lathe machine. So as of now, we have concluded the lathe machine and its operations, and lastly we have seen the specifications. So lathe machine is a very versatile machine on which we can do multiple operations. We can do different types of operations on a lathe machine. Okay, depending on the application or depending on the type of operation being done, we have to choose a particular lathe machine. Okay, some lathe machines are like engine lathe is suitable for doing multiple operations. Spindle lathe is suitable for doing very small objects separately. So this is all about lathe machines, and we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.